Today we look at the process of elimination, Chapter 6, Section 3. In order to minimize the necessary time, because remember we're taking this test next Friday, we're going to focus on looking at the necessary steps to solve a system by elimination. Again, make sure you take good notes, make sure you pay attention to what's going on, otherwise things can get kind of messed up. The goal of elimination, the word eliminate, means you're going to cancel something out to find something else. So you're going to get rid of one of the variables. Sometimes in some of the easy questions the variable's already set up to be canceled. So look at the following problems with me. We're not going to go all the way through them because I think you know how to finish them. But once you find the first answer, we should be good. But if you look at this system, 3x plus y equals 6, 5x minus y equals 10, notice how our y's are opposites. Which means at this point that if I simply added up all the terms, 3x plus 5x makes 8x. Y minus y is gone, which means it's eliminated, which is the whole purpose of elimination, equals 6 plus 10, which is 16. Dividing both sides by 8, you find out that x is equal to 2, and again you would take that 2, plug it in to find your value of y, but we're not going to do that today because I think you know about this. You should know about the second process, so we're going to save time by not completing these problems, but you'll have to whenever you do your work. The second problem works the same way. 6x plus 3y equals 4, x minus 3y equals 10. Again, looking at this, we already have a variable that is opposite of itself. So we can simply take 6x and x and make 7x. 3y and negative 3y go away. 4 and 10 make 14. Dividing by 7, we find out that x is equal to 2. Also kind of boring, but you get the general idea that all we have to do if the variables are opposite is add up all the parts. Once the variable has been eliminated and we have one solution, again the process is the same. You simply rewrite one of the equations and substitute the value that we know in order to find the second. So let's look at a couple examples of problems. Which problems that are almost ready to cancel. So we had the first type, which are problems that are ready to cancel. The second type is problems that are almost ready to cancel. So we are slowly learning that there are two tools that you're going to learn or use. The first one's showing up right now. Here we have 8x plus 5y equals 11 and 3x plus 5y equals 1. These two aren't ready to go, but they're very ready to go, which means that if all I could do is just turn that to be a negative number, then I could make it what I need to be. The rule of algebra says that I can switch that to be a negative as long as I switch everything in that equation. So what we will do is simply switch all of the signs, and that is all. So again, that skill is one of your processes of elimination, because now that my 5's are opposites, I do 8 minus 3 is equal to 5x. 5 minus 5 is gone. 11 minus 1 is 10. Divide both sides by 5. Getting x is equal to 2. Again, plugging that in, finding y would be how you would finish that up, but we're not going to do that because I'm trying to save you some time. Same thing on the second one, 2x plus 3y equals 4, 2x minus y equals negative 4. These two are almost ready to go, they're just not opposite, so what we will do again is switch the bottom row. And when you do that, now these go away. 3y plus y is equal to 4y. 4 plus 4 is equal to 8. Sorry, I guess I just keep getting the same answer over and over, which means I really wasn't creative, but y is equal to 2 there. If you want x, plug it in, solve the way you've learned before. Again, this takes us to our first solution and sets us up perfectly to finish the problem. There is a third type of problem that requires a bit more creativity. If no variable is either ready to cancel or almost ready to cancel, I typically focus on making the x's go away by using the distributive property. So consider the following statements. We know that 1 plus 2 is equal to 3. But what if I took that and simply multiplied everything in there by 2? 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Notice that 2 plus 4 is still 6, which means that this is still a true statement. Even though I took everything in here and simply doubled it, everything still ended up the same. It's still balanced out as an equation. Same thing if I decided to multiply everything by 5. Instead of 1 plus 2 equals 3, I get 5 plus 10 equals 15, which again is a true statement, which means that multiplying everything may make the numbers look different, but the value is still a true, or the equation is still a true equation. And so we're going to use this property on a high level of elimination problems. So let's look at some of the examples today. Again, I'm only going to work out the first solution. Do not get in the habit of simply working out the first solution. When you do your work today, you're going to need both. But again, as I said, once you have the first solution, you should be okay to find the second. So here, 2x plus 3y equals 9, x plus 5y equals 8. My x's aren't ready to go, my y's aren't ready to go, neither one of them is close, but what I can do is say I could turn this into a 2x by simply multiplying everything here by 2. The hardest part of this process is that people forget to multiply everything, but either way, the first equation stays the same, 2x plus 3y equals 9. The second equation turns into 2x plus 10y equals 16. Again, 2x, 10y, 16. Now that these are very close, what we're going to do is simply switch all our signs, which then gives us x is going away. 3 minus 10 is negative 7y. 9 minus 16 is negative 7. Using the solving that we've learned already, we find out that y is equal to 1. Again, you can take that 1, plug it back in to find your other answer, but we are not going to do that for the sake of your notes, because once you have that answer, you should be able to do the rest of it. So again, multiply. Once those 2's were close, switch all the signs on that bottom row like we did in the second type of example we talked about today, and then from there the problem finishes itself up. B, 3x plus y is equal to 5. 2x minus 2y is equal to 2. Nothing's ready to go, nothing's even close, so what we're going to do here is make 3 and 2 meet. Kind of like a least common multiple, but it really doesn't matter as long as they meet somewhere. So what I will do is multiply this by 2, because that'll turn that into 6, and I'll multiply this by 3. Typically it works that way, where you can take this number, move it down, take that number, move it up, and everything will work out. Notice either way that we do get a 6x plus 2y equals 10, and we get another 6x, which is good, minus 6y equals negative 6. So again, 6x, 2y, 10, 6x, 6y, 6. Almost ready to go. All we have to do is switch our signs over and combine our terms. So this goes away, giving me 8y is equal to 16, which means that y is equal to 2. And again, we would do more work taking that 2, plugging it in here, and figuring out exactly what the value of x is, but for the sake of time, we are just going to focus, I'm going to focus the notes on just finding the first answer. So make sure you get that down, make sure you take some good notes on this, and again, make sure you're ready to perform on that, because this is really the last hard part of this unit, which is elimination. C has 3x equals 5 minus 2y, and it has 5y equals 16 minus 4x. This is an ugly question, but again, luckily we know how to solve for variables, so what we're going to do is put both of these in standard form by adding 2y to both sides. This turns into 3x plus 2y equals 5. Again, all I did is turn my negative 2 to a positive 2 and put them in order. Same thing here. If I want my x away from the constant, I'm going to add 4x to both sides, and I'm going to put my x first, so I'm going to put 4x plus 5y equals 16. And once I have that, my equation is set up. Notice again, it was necessary for me to change the sign on both of the things I moved, and from there you just go ahead and get it done. 3 and 4 meet at 12, so I'm going to multiply the top equation by 4, the bottom equation by 3, which gives us 12x, 8y, and 20. 12x, 15y, and I think 48. Again, 12x, not really ready to go yet, so what we will do is switch to the signs on the bottom row. You don't always have to do the bottom row, but notice that I do cross out my plus before I turn into a negative. These go away, giving me negative 7y is equal to negative 28, which means that 7y is equal to 28, and when I divide by 7, I get the answer of y equals 4. Once again, before you make a bad habit of it, take the 4, plug it in, and get the x, but we're not doing that for the sake of these notes, because I just want to make sure you can get the first answer. Overall, this process is pretty direct, but it's up to you to practice, ask questions, and understand that you only have 2 weeks on this unit, and really less than 2 weeks, because this would represent Wednesday, and you are now down to Thursday, Friday, and then Monday through Thursday of next week. So take the process very seriously, or expect to miss a lot of questions next Friday. But again, before moving on to Math XL, let's look at some more problems that we are going to complete. Actually, a couple problems that we're going to complete, and just kind of make sure we understand in terms of the word problem application. 6x plus 10y equals 6, 3x minus 15y equals negative 5. If you look at 3, I could multiply 3 up here, 6 down there, but I think I could just turn that into a 6 by multiplying by 2. So I get 6x plus 10y equals 6. I get 6x minus 30y equals negative 10, which turns into a negative, negative, and a positive. When I go to do my work here, those go away. I get 40y equals 16, which is a very ugly question, but it's okay. Divide both sides by 40. Reducing this, I think you get 2/5 as your first answer. And if you don't know, you can always take the calculator, type in 16 divided by 40, math, enter, enter, and you see that it is 2/5. And so now I will take this 2/5. Again, I'm going to finish these out and plug it into here. So 6x plus 10y equals 6. 6x plus 10 times 2/5 equals 6. And again, remember that the whole number goes to the top. So you end up with 6x plus 20 over 5 equals 6, which of course turns into 6x plus 4 equals 6. Subtracting 4 from both sides, you get 6x equals 2, which when you divide by 6, you get the answer of 2 6 can be reduced 1/3. And so based off of what I see, my answer is 1/3, 2/5. And remember, all you have to do to check it is take those two numbers to the other equation. Since I used the top, I'm going to check out the bottom one. So 3 times 1/3 minus 15 times 2/5 hopefully equals negative 5. We see that it does, which means that that is the right answer. It's just an ugly answer. And as I said, you will see ugly answers on the test and on the Math Excel. So just be ready to work those things out and be ready for that. Alright. Last question we're going to talk about here is a word problem. Each of the squares in the figure of the right has the same area. Each of the triangles has the same area. It says the total of figure A is 141. Total area for figure B, that should be squared and squared, I just didn't change it, is 196 units squared. What is the area of each square and each triangle? This is a problem that you've never seen before, but you can use it to your advantage. It says that all the squares are equal and all the triangles are equal. So what I'm going to do is use a S for square and a small t for triangle. In figure A, I have 1 square and 4 triangles. And it says that that area is 141. So 1 square and 4 triangles equals 141. Here I have 2 squares plus 2 triangles equals a total of 196. So again, 1 square, 4 triangles is 141 because that's figure A. 2 squares, 2 triangles makes 196 because that's figure B. All I have to do now is solve it. I'll multiply the top by 2 because remember I like to focus on the front one. 2s plus 8t equals 282. Leave this alone. 2s plus 2t equals 196. Switching on my bottom row signs, you end up with 6t is equal to, I don't know, I could probably do that, but I don't want to mess with it. 282 minus 196, which is 86. At least I hope it is. Is it? I don't know. 282, that is 282 and 196, which is 86. And then when you divide by 6, I don't think it works out the way we want to. Of course not. So we end up with 86 divided by 6, which of course is 14 1/3. This is going to be beautiful. And so if you want the triangle also, you have to kind of take that back up here and hope it works. I don't think it's going to work. I think I messed up somewhere, but I hope you get the right idea on the beginning of it. Let's just see what happens. So we have s plus 4t equals 141. Let's make sure I did everything right here. 2s, 8t, 282, which is right, 2, 2, and 196. Switched it, 6, 86, which we know for a fact is true. Alright, we'll trust it. So we get s plus 4 times, instead of 14 1/3, let's turn that into a mixed number, or improper fraction. Remember that we take 3 times 14, and then we add the 1, which is 43 over 3. Very ugly. Equals 141. Let's see how this works out. Then when you take and multiply those, again the 4 goes to the top, so s plus, I don't know, 160, 172 over 3. Yep. Equals 141. 172 divided by 3, I think just stays 172 over 3. But what we know to do here, if you remember the day that we talked about this, is get rid of the fraction by multiplying everything by 3. And it's going to make a much bigger mess, but at least it'll get rid of the fractions. So those 3's cancel. 141 times 3 equals 423. And now you subtract your 172. Which gives me 251. And then dividing by 3, you end up with S equal to, how many times is 3 going to 251? Which is 86, and this would be 86 and 2/3. Typically, whenever you see a bunch of 6's, that's how it works. Now let's just see if this answer was just a mean question in general. So we have a square, which is 86. I guess 251 over 3 is how we're going to say that. Plus 4 triangles, which we'll type in as 43 over 3. Look at that. They were just mean. It actually is 141, and then the 2 squares, so 2 times the squares, which is 251 divided by 3, plus 2 triangles, which was your 43 over 3, is your 196. That was just a very mean question. I apologize if I intimidated you a little bit, but again, the bottom line is we know how to do all this stuff. The key part there was to make sure you understood how to turn that into a improper fraction. Bottom times whole number plus the top gave you 43, leave the bottom number alone, and then use your ability to eliminate fractions to work through the rest of that. Other than that, before you get ready on your Math XL, I want you to graph 2 problems. The first one's going to be y is equal to y is equal to 3x minus 5, and your second's going to be graph 4x minus 5y equals negative 20. So get those 2 turned in. Again, if you want help on the work today, you have to make sure you hand that work in if you want my assistance. Other than that, good luck, and again, make sure you're keeping up and practicing and studying your notes, because this honestly represents the last of the difficult work. The rest of it allows you now time to get your substitution elimination skill down so you can master it for the test.